Okay, so essentially what's going on with the enthalpy of reactions is you can conceptually view it as the molecules are, each one of your reactants products are getting broken apart into their constituent atoms and then reformed. So this is essentially the amount of energy that it takes to rip the atoms apart. That's how much you get from forming them back, right? And so the difference in energy is the energy that's released by the reaction. We can use this sort of idea and on understanding that the values from our computations, our theoretical values, should align with the experimental values. So if we do the change in energy for a reaction from experimental values, that value should equal the enthalpy of reaction for a theoretical value. Breaking up each one of these into our subcomponents, this would be change in enthalpy, the sum of enthalpy of formation of the products that are from experimental sources minus the sum of the enthalpy of formation of the reactants from experimental values. That is equal to the enthalpy, the sum of the enthalpy of formation of the products from theoretical minus the sum of the enthalpy of formation of the reactants of theoretical values. Okay, so the what we can do is find the enthalpy of formation of each one of these. So this is essentially the reaction that we're going to be doing, right? This is our reactant. These are our products, right? We can look up, and we're going to go to a online source, CCC BDB. It's done through the National Institute of Standards and Technology. It's a huge repository of enthalpy of formation values, right? So we're going to grab the enthalpy of formation, the experimental values for carbon as an atom, hydrogen as an atom. We're going to use those for, well, we can use them for our products here. So those are going to be our products. This is the value that we're trying to figure out, right? In theory, what should our experimental value of formation, our experimental enthalpy of formation be for this one, right? The molecule that you're calculating. These two sets of values, the enthalpy of formation of the products for these, you calculated out an individual one, and so you would have to multiply how many carbons you have by that value, then add how many hydrogens you have times the value for hydrogen. We'll go through an example. Okay, so that would be this one, and then this is the enthalpy that you get for, that you calculated for this value. Okay, that should also be in the table. So you're going to take the sum of the calculated values for the carbon plus the hydrogen, subtract off the calculated value for the molecule that you're interested in. Okay. Now these values here are in Hartrees, so we're going to need to multiply them by the was it 2625 that converts from Hartrees to kilojoules per mole. I think it's 26.25. Sorry, 2625.5. Okay, so if we want to solve for this one, we can move this to the other side, move both of these to the left. Right, essentially solve for this one. You would get the sum, enthalpy of formation of the products, experimental, minus everything you had over here, sum, theoretical, minus the sum, now, because these are in Hartree's, we're going to need to multiply this by our conversion factor, where our conversion factor is 2625, and that converts it into, the conversion is kilojoules per mole Hartree. These are currently in Hartree, so the Hartree cancels out, and you get back kilojoules per mole. Okay, that will equal, now if we look at the reactant, there's only one molecule, right, in the system that we're doing, and so what you would get back would be the enthalpy of formation for C and H, right, which is what we're going to be trying to find. You will be comparing that to the literature values that you're also going to find on CCC, BDB. Okay, and then we're going to be evaluating how accurate our method is. You know, the method basis at how good are they. We can then also do the exact same thing for the CBSQ B3 value and see how good that one is. Okay?
We don't have the CBSQ3 values yet, right? We have to run all the molecules again.
No, you're going to be doing it just for hydrogen, carbon, H2, and methane. The problem with a CBSQ B3 is they take a lot longer, and so we're only doing the smallest of the group. And it's meant to give you an idea of, these are what we call sort of research grade. This is the CBSQ B3 is what gets published a lot, and so it's sort of more publication grade methods, whereas the other stuff that you're doing isn't. It still gets published in some journals, but it really shouldn't. So we're going to be able to evaluate how close the values are, how accurate everything is. Okay? Now, the values that you're calculating, the values from the computations currently are at 0 Kelvin. So we got to make sure that the values that we pull from the database are the ones at 0 Kelvin. Okay? So, let's see. If you go to, look for sort of a internet window, CCC, BDB, click on experimental data. Okay, and then you can just write the chemical formula for the one that you're interested in. For the first two values, we're interested in hydrogen, H as itself, and then carbon as itself. So you can just type H. We want the hydrogen data. The value that we're after is the H, the enthalpy of formation, so this would be HF for the gas at 0 Kelvin. Can you redo that? Sure. So, CCC, BDB. Good. Then we want the experimental data. Good. Okay, and then right here, it's where you can type in the chemical formula, we want hydrogen, so you type in just H, and it'll take you to this site. So this has a whole bunch of stuff that's gonna be, that could be useful, but what we're really after is this value right here.
I don't get the experimental. We don't need the whole thing.
Okay. Now, if you want, you could possibly bookmark the CCC BDB. It will be a useful site for you to use. Okay? So, what we can do is someone previously sent me their data. You did? Okay, can you send it again?
Do the Excel or?
Oh, if you got it already in Excel, that would be great.
So what's the part that we need in Excel, like all the charts here?
The enthalpy of formation values. Yeah, essentially all those values.
On this?
Oh, sorry. These values, we're gonna then use them to fill out these values.
So I go to my model, search up and see.
So the search values are gonna go here. And the enthalpy of formation literature values. These are ones that you're gonna have to calculate, using WebML.
Right, so I would put just carbon, fine.
Mm-hmm.
What is, can I come by? Just ask you.
Yeah, once we get started, I'll, get you going on that. Okay. Sent?
Yeah.
Okay. Okay. So I like to keep my reference values on a separate sheet. I just think it makes it more organized, less values all over the place. Guess we don't necessarily have to do it that way. Okay, so this top table is probably gonna be the most useful one for this purpose. there so that we have a way of calculating our enthalpy of formation values. Give us a little bit more room. That's right. Make a column for enthalpy of formation, and then we'll just write down the values for these first two. That's the carbon and the hydrogen that we get from our
Could you zoom in a bit?
huh?
Could you zoom in a bit?
Is that better? Okay. So we're gonna put the values from the CCCBDB into that column. So grabbing .04. Same thing for carbon. For carbon, we're going for the ground state. So you want to have the top one marked. Let's see. 711.19. Okay. Now, you will end up filling out the rest of these, grabbing them from the CCCBDB for your other molecules. Okay. That'll be handy for you to have two columns to work with. One, we're gonna have this, the number of hydrogens. The next one, the number of carbons. Okay. You guys know the freeze panes option in, okay. So if you go to the view in Excel,
Which ones were created?
so what we're gonna do is click on the upper left portion. So we want these headers to be visible and everything along this row to be visible. Alright, so essentially as Caroline has it, A and 2. We want those to be visible, so you're gonna put your cursor on B3. Then up here in the view, there's this option that says freeze panes. Click on that. We want to freeze the panes as opposed to freezing row. Freeze panes. Yeah. Now if you scroll left, no, sorry, you gotta be down here. Going left, it'll keep. So for you, you want to be able to see this one. Yeah, that's where you want to do it when you're doing freeze pane. If you click freeze pane, be able to now click it again to now freeze the panes. There, now if you scroll to the left, it'll keep your left header. And if you scroll down, it'll keep your top header. Okay? Did you get it to work? Nope. Okay, to you scroll left and right, it should keep your headers. That typically makes stuff a lot easier to fill out. You get it to work? Okay. So, what we want to do in this column here, in these two columns, the number of carbons and the number of hydrogens, is essentially write out what the chemical formula looks like. Alright, so this one has 2 hydrogens, that one has 4, 6, 8, 10. H2 has 0 carbons, methane has 1, then 2, then 3, then 4. Okay, the reason we're doing this is we can set up a formula in Excel to automatically calculate stuff, and so you won't have to type it in manually for everything. Okay, so the first one here, we're going to do this one as the atomization. The next one will be our delta H formation values. Right? And you can take that, copy it, paste along all the others. So your atomization would be this reaction here. Right, so it would be your products minus your reactants.
Okay, what's that?
How did you paste it?
Control C, highlight the region, Control V, or Command C, Command V.
So where did that come from? The first one?
Yeah, I just copied the first one, pasted it over, and have the values lined up.
I was gonna copy and paste it out for them. I'm not sure how to do like all of them.
That's fine. If it works, it works.
But how, just to know, so like you just copied
I
this.
copied the first two. Then highlight this whole range. And you can see it in Control V. Okay. Everyone up to speed? Go. Okay.
This sheet is just sold.
Well, these numbers look okay, but that's okay. Just delete those ones. Okay, it looks like it's being used for that one. Control Z a couple times. You're fine. Okay. Highlight those, and then just insert. There we go, okay. So to find the atomization energies, it's the sum of the products minus the sum of the reactants. The products are our values, our calculated values for the C and the H, right? And then we're going to subtract off the value for this one. So for hydrogen, this would be equal to, I'm going to put a set of parentheses around, we're going to do parentheses our products, get all those together, and then minus parentheses around all our reactants. So this one will be equal to the location or the column that has the number of hydrogens. If you're using a Mac, it's Command T. If you're using a PC, it's F4. Okay, and cycle you through the absolute and relative addressing. Have you guys used absolute and relative addressing? No? Okay. So,
This is the dollar sign, isn't it?
yeah, that's the dollar sign.
Can this lab be worth like 5 points?
Hmm?
This lab is just like dialed up to like 5 points and have to kind of just omit it.
No. So, what the dollar signs do is they lock that particular element in place. So when you're copying things around in Excel, normally what it does is if you copy it across a row, it will change the column header. If you copy it down, it'll change the row header. By putting a dollar sign in front of things, it locks it in place so that as you copy it either across or down, the value that's right next to the dollar sign or the value that's directly to the right of the dollar sign stays fixed. Right? We use that so that as you're moving stuff around, you can have formulas that, well, in the case that we're going to be doing, is we're going to set it up so that this one, we're going to eventually copy this down, and then we're going to copy it across. As we copy it down, we want it to always reference the correct row. Right, so the values that are in here are the number of hydrogens. So if we copy it down, we want it to change. But if we copy it across, we don't. Right, so the atomization for the STO3G should take reference to 2 hydrogens. For the 321 should also be 2 hydrogens. So this entire row should be trying to grab 2 hydrogens. So as we copy it across, we don't want it to change. But when we go down, this one needs to be with reference to 4 hydrogens, right? Then 6, then 8, then 10. So as we copy it down, we want the designator of the row to change. But when we copy it across, we don't want the column designator to change. So we want to have a dollar sign in front of the L, so that as we copy it across, it stays L. But as we copy it down, we want it to say row 6, row 7, row 8, row 9, row 10. Okay, so we're going to have $L and then no dollar sign 6.
No dollar sign?
No dollar sign in front of the 6. So if you're on a Mac, as each time you push Command T, it will cycle through your options. Right? So you have L, your options are, we currently have L6. So you could have $, L, $6. And the next one is L, $6, and then the last one would be $L6. Right, those are the 4 ways of setting these up. This one, the top one, the default, as you copy and paste it around, it will change based on location. So if you copy it to the right, the L will change, and if you copy it up and down, the 6 will change. This one, wherever you copy it, it's always going to be referencing the cell the value that's in cell L6. This one, as you copy it down, the 6 stays, but as you copy it across, the L is going to change. Right? Typically you use this one if you're wanting to use a value that's in a header. Right? So if you have like energy versus temperature, or you have an equation that goes by temperature, and you're copying it across, it would then track with that. What we want is we want to go, as we copy it down, the row indicator changes, but the column indicator doesn't. So we want $, L, and then 6. So
How do you do that on the PC?
PC F4.
When I PC, well, it's like more, I'll just give it for Jack.
Oh, you might have to do function F4. The function button. No? Yeah. You can also manually type it in. Okay? So, that one's locked in place. Now what we're going to do is we're going to grab the value associated with hydrogen for the STO3G. So if we scroll to the left, so we're going to take the number of hydrogen times the value for hydrogen at STO3G, which is this value right here. It's B5. Now, thinking about what we're going to be doing, we're going to copy it down and across. If we copy it down, we don't want it to change, right? Because right now, if we copy what we're doing down, it will then be using the value for H2, and then methane, ethane, propane, butane. We want it to, because our products are always going to be relative to hydrogen and carbon, we want it to stay the same as we copy it down. But as we copy it across, we want it to go to the new theory when we get there, right? So we want it to stay the same as we go down, but change as we go across. So, what are our $ things going to be? We want to stay the same as we go down, but to change as we go across. So, which one gets the $? The number or the letter?
Letter.
The number. Because the number indicates the row. When we copy it down, the number would be changing. So it's this one here. We want the number, we want the row designator to stay the same. So, we're going to take that B5.
Wait, so if you want the road, like if you want the value to stay the same page, right?
Mm-hmm.
And if it's in, like, let's say if it's in column E, right?
Mm-hmm.
Wouldn't you want to fix that? So what did you put a $? E? So you don't want it to change, right?
If you put a $ in front of the E, it locks it from changing left to right.
Yeah.
But as this is currently written, we're going to eventually be copying it so that we can use it for the different theories.
Oh,
The
okay.
theories
So
are vertical.
You want to put change.
Yeah. So if we put a $ in front of, in this case, the 5, right? That will lock it so that as we copy it down, it always is referenced to the row for H. Okay? We're going to do the exact same thing. So we now have the energy contribution from hydrogen. We're going to now add the energy contribution from carbon, which is the same process except using the values for carbon.
Just to make sure it's $B5.
As hers is written.
Yeah.
So it's
$sign
the wait a minute. No, it's B $5.
So we want the row to stay the same?
Yes.
Alright, that's what I had.
Yep.
Press enter?
No, plus.
Parentheses
That's-
in?
Huh? Nope. We are putting parentheses around all of our products. Okay. Then we're gonna do the value that's stored in carbon, right? And so this one again is gonna be $ letter number without the $, times. So then we're gonna grab, in this case, B4, and we're gonna put the $ in front of the number. That is the value for all of our products.
Multiply.
So, minus,
We're doing minus?
plus. Okay, so we're gonna take that, and now we're gonna subtract, set of parentheses, and we're gonna click on all of our reactants. In this case, we only have one. So, our reactant, so minus, open parenthesis if you want, hydrogen, close parenthesis, this one should change as you go down and as you go across. So we'll leave it as is.
Which one's that, the B5, B6?
Basically hydrogen two.
H2, so that would be B6.
Mine's like only these.
Okay? Now, the reason why we want to be very careful about doing all this is we can now just grab this, drag it down, they autofill, grab this, drag it to the right, they all autofill. The reason why you have value and whatnot is if you look back at your data, these values here, every other one is a calculation time and not actually Hartrees.
Like, will that be the table you just like, hot for?
Yeah.
I have, I have those two.
So you?
Oh, okay. So, Carolyn, the reason that it's throwing an error is when you copied and pasted this over from Word, I think there's either a space or a return after the number, and so it's treating it as text as opposed to a number. So if you go into the actual value up here, right? Yeah, there's a space there. The 6-31GD.
So if mine has like, that error message value.
Yeah, likely when you copied and pasted it over, there was a space in what you were copying and pasting.
I think it's only that.
I think we were using them as your indicators benchmark.
So if it's a number, it should be right justified. This one is not. So here, yeah, space. There you go. So here,
So on that field.
and that one, and then this one.
Yep.
So open. On that, so you click up top. No, single click. Oh, hit enter. No, hit enter. Press it, hit enter. Control Z.
Yeah.
Then hit enter. There you go. Okay. Okay. Yeah.
Where to
Got it sorted? Okay.
But then on this side, ours is different.
Why did it just try?
No. Yours is off by one. That last column shouldn't be there. So when you started here, this column should be lining up with that header. You have an extra column. So you. The last column that you guys have
Yeah.
doesn't actually exist.
Okay, so.
So just delete this and change.
Or you can just shift your header to the left one. And right those two. Okay, right click. Delete. And you shift cells left. Oh, this column needs. Yeah, essentially you copied it one row too far. So
Those
yeah.
numbers are on.
Huh?
Those numbers that I had from my table. Like, okay, this table, I know where it came from. This tool we made, I know where it came from. This is gonna be from the website. This is what we just did right now. What is this?
Those are numbers that you were using.
Oh, I can't do those.
No.
Skip it. Okay, this is.
Okay. So, the values that are next to the ones that we did, essentially I was, by copying and pasting them down and across, we weren't quite ready to copy them across. But the point was to see how using the dollar signs, kept it where it should be as we copied it down and across. So if you click on, let's say the atomization here for the bottom one, right, it should, in terms of the cells that it should be pointing to, it should be pointing to these two, right? The values up here for 321G for the hydrogen, carbon, and then the butane, right? So if you click up top, up here, it will show you what cells you're using in your equation. So if we shift to the right, using the ones we said it was going to use. It was using the two over there, this one, that one, and that one. Okay, now, we didn't yet figure out our enthalpy of formation values, right? So what we need to do is calculate out these delta HF. So we're essentially going to use this equation here, right?
Which one?
This equation on the bottom. Okay, so the atomization energies that we currently have are in Hartree's. We want them to be in kilojoules per mole. So we can take these values, if we wrap our original function in another set of parentheses.
So you started at DHF 0 at,
I'm modifying what we just did, taking this, wrapping it in a set of parentheses, and then I'm going to multiply it by 2625.5, our conversion factor to go from Hartree's to kilojoules.
for which cell?
Mhm.
N6.
Yeah, N6. The one that had this equation in it, the one that we were working with before. So, times 2625.5. There we go. That is our atomization energy in kilojoules per mole. It should be a really big number because atomizing atoms or atomizing molecules is not an easy process.
And we put across.
No, not yet.
Just
We're going to fill in this one, and then we're going to copy it across. So, this whole value here is what we just calculated. Right, this is our delta H atomization. So, in our cell here, this one would be equal. We essentially need to figure out what the enthalpy of formation, the sum of the enthalpy of formation of our products is, and then subtract off the cell that's right next to it. So we're going to do a similar process to what we did before. We're going to take the number of hydrogens times the value for hydrogen plus the number of carbons times the value for carbons, right? And we add them all together, and that will give us the total enthalpy of formation for our products. That make sense?
One more time.
Okay. We're going to take the number of hydrogens times the enthalpy of formation of the hydrogens plus the number of carbons times the enthalpy of formation of the carbons, add all those together, and that would be our total enthalpy of formation for all of our products. Right? That would be this value. Then you're going to subtract from that the value sitting right next to it. The answer would then be the enthalpy of formation of the molecule that you want. So when we do this for the hydrogen, we should get something close to 0 if everything works out right. And if the particular computational method that we were using was super accurate, which STO3G is not. So this will be equal, open parentheses, it's equal to the hydrogen times the enthalpy of formation for hydrogen plus carbon times the enthalpy of formation for the carbon. Now, before we finish that off, what we want to be able to do is copy and paste this around like we did before, right? So we got to decide where we're going to put the dollar signs.
Oh,
I will write it out. So, our new line is, we currently have L6 times J5 And I'm giving myself room here to write in the dollar signs once we figure out where they're gonna go. Plus, M6, give myself a little bit more room, M6 times J4. Okay, so where am I putting the dollar signs? This L is this one. Do I want it to change as I go across?
No,
No. So what do I put it in front of? The letter or the number?
the
The letter, right? But I do want it to change as I go down. So I'm gonna put the dollar sign in front of the letter, but not the number. J5.
You want both?
Hmm?
Both?
Yes, I want it for both. This is enthalpy of formation values. They do not change, right? And so for this one, I want it to stay always referencing the enthalpy of formation of a hydrogen atom. What about for the next one, M6? Do I want it to change as it goes down? Yes. Do I want it to change as it goes across? No. So where do I put the dollar sign? For the letter or the number? The letter. Right? I want the letter to stay the same. I want it to always refer to the M column, but I want it, as I copy it down, if I move to the 7th row, I want it to use the value in the 7th row. If I move to the 8th row, I want it to use the 8th row, right? So dollar sign in front of the M, nothing in front of the 6. What about J4? That's the enthalpy, the literature enthalpy of formation value for carbon. Fixed. So dollar signs where? For both of them. Okay, and then you're going to subtract from this the one that's right next to it. So that would be
Wait, minus is at 10.
N6. The what?
Minus is, what do you want to see?
Table. You don't want to create a table. You hit the wrong button. Don't know. Okay, so we're going to take this, subtract off the value that's sitting right next to it. Now, what do we want this one to do? Do we want it to change as it goes down? Yes. Do we want it to change as it goes across? What do you think?
Yes.
Yes, right? Because we're saying the enthalpy of formation of the this method minus the atomization energy of the same method, right? So as we move it over to here, we're now changing the basis set, and so we want it to align with a new basis set. Okay, so this one, the N6 is going to stay N6, no dollar signs. So we hit enter. That should be 0. It is not.
Minus negative
Oh.
567.
That is because while I said where we're going to put the dollar signs, I wrote it up on the board and didn't actually do it on mine.
What's the same value?
Hmm?
It's the same value.
Yeah, because I didn't put the dollar signs in.
Minus negative 567.
Hold on. Yours are all the same?
So we have the same as that.
And you said it should be close to zero, right?
It should be,
Mine's like negative 567.
yeah.
Why?
That's speaking to the accuracy
Oh,
of that method.
is that no?
Remember when I said some methods are publishable and some are not? This is the very much not.
So it's not anything wrong with the calculation, it's just.
There might be, but the end result is not gonna necessarily be close.
So is that,
Yeah, that's right. This particular method is, you don't publish this. This is what you use to do an initial optimization of geometries, but you wouldn't use it to publish because the numerical values are
STO.
not good.
3D.
Now, if we copy and paste this over, our value should get better. Yeah, there we go. That one's within 28. All right, hydrogen itself should be 0. The other ones we'll have to look up. But you can see that it improved.
Mine's just error.
It's circular reference